Okay, welcome to day 2 of the countdown, day 3 of the countdown to the AP exam. Today we're going to look at a 2016 free response question, and we're going to look at implicit differentiation, Euler's method, L'Hopital rule, and the second derivative test. So let's just give some examples of each of those. So if you remember Euler's method, we take to find the new value, we start with the old y, add that to the step times the derivative, evaluate it at x old and y old. That's Euler's method, and we use Euler's method to approximate a function when we're given its derivative. Then L'Hopital rule, we use that when we're finding the limit, and the limit is indeterminate. So before we can use L'Hopital, we have to state that it's indeterminate by either saying that it's infinity over infinity or 0 over 0. Once we've determined that it's indeterminate, then we take the derivative of the numerator and the derivative of the denominator, and then we take the limit as x approaches a to find a value. If it's still indeterminate, then we can keep doing L'Hopital until it's no longer indeterminate. The other thing that we need to remember is the second derivative test. The second derivative test is not the test for concavity. Okay? We use the second derivative to find concavity, but the second derivative test is not the test for concavity. The second derivative test says this: if the first derivative at c is 0, and the second derivative at c is greater than 0, indicating the function is concave up. So if it's concave up, looking at that, I can see I'm going to have a local minimum. If the second derivative of c is greater than 0, is less than 0, then that means that the function is concave down, which is going to produce a local max. If the second derivative is 0, the test is not informative, meaning we'd have to use another test, probably the first derivative test. Okay, so this is problem number 5, I think, from 2016. So the first thing we want to do is we want to look at the derivative, because they asked us to find the second derivative. It's question number 4. They asked us to find the second derivative, so I have to find the second derivative of this. Your first instinct may be to separate variables, but you can, at a quick look, you can see you don't have the ability to separate variables here. That's something you may learn in Calc 3, but at this moment you don't have the ability to separate variables. So what you want to do is simply find the second derivative using implicit. So dy dx using implicit would give us, implicit differentiation would give us 1/2 dy dx. Now the problem states that they want it in terms of x and y, which means I can't leave this as dy dx. So this has to be the second derivative is equal to 2x minus 1/2, and my original derivative is x squared minus 1/2 y. And you don't have to go any further. That is all you need for that, and you got 2 points for this, and I think it was all or nothing. So either you got this and you got 2 points, or you didn't. So it's all or nothing. All right, for B, it asks us if we have a relative min or a relative max or neither at -2,8. So this is where using the second derivative test is going to come in handy, because the first derivative evaluated at -2,8. So I'm just putting -2 and 8 into this formula. So that gives me -2 squared minus 1/2 times 8. That's 2 comma 8, by the way. And that gives me 4 minus 4, which is 0. So I proved the first part of the second derivative test. The second part of the second derivative test, I have to see if that second derivative is positive or negative. So putting these values into the second derivative, which we found a second ago. I'm just going to write it here. The second derivative was 2x minus 1/2 x squared minus 1/2 y. Okay? So evaluating negative 2, 8 in the second derivative, I get 2 times negative 2 minus 1/2. Negative 2 squared is 4, minus 1/2 of 8, which is 4. So that gives me 0 again. So the second derivative is negative 4. So what does that tell me? Well, this is what I would say. This produces a local max. So the way I would write that, because you answered the question that you're given. So they asked you, is it a local max or a local min? So you have to say that negative 2, 8 is they use the term relative, local are the same, is a local max because y prime at negative 2 is 0 and y double prime at negative 2 is negative. Okay? So because it's negative, that means it's concave down, it's going to be a local max. That's all you need to put. You want to be careful in writing too much. As my teacher friend likes to say, you want to be concise and precise. So that's all you want to write. It's a local max, and you had to state that the first derivative was 0 and the second derivative was negative. Because in order to use the second derivative test, you have to make sure that both parts of the test are true. You also could not have used the first derivative test, so you could not have done a sign chart on this. So you could not say that it is a local max because the derivative went from positive to negative. You don't know that. You don't have enough information to determine that, so you couldn't use that statement. You had to use the second derivative test. And I've seen on the last 5 tests or so, you always have to use, where they give you a question where you have to use the second derivative test. Okay, the next one we're going to use L'Hopital. So here's I love this question because there's so many things coming into play. The first thing you need to do before using L'Hopital, you have to prove that you can use L'Hopital. So you have to say the limit as x approaches negative 1 of g of x minus 2 over 3x plus 1 squared. You have to say somehow that gave you 0 over 0, which was indeterminate. Indeterminate. My students laughed at the way I spelled that today, so I'm going to spell it right. You had to state this. You have to write indeterminate. Okay? So how do we know that? Well, we're told that g of negative 1 is 2, so we're given that piece of information. So 2 minus 2 is 0, and then negative 1 plus 1 is 0, so that's 0 over 0. So that makes it indeterminate, and you have to state that. The second thing you have to state when you're doing that, so then you're going to say, I'm going to use L'Hopital. So you want to state that you're using L'Hopital. So I'm going to write L'Hopital applies, okay, which indicates that I'm using L'Hopital. The third thing that you need to be careful of is that you use limit notation. If you do not write the limit as x approaches negative 1, they will not give you credit. So you have to say the limit as x approaches negative 1 of g prime of x over 6x plus 1. Okay? So now I have to find g prime of x at negative 1. Well, we're told that y is equal to g of x. So g prime of x, I would evaluate that for this equation. So this would give me negative 1 squared minus 1/2. G of 1 is 2, so this is 2. G of negative 1 is 2. So that's 2, and look, I get it again, I get 0 over 0. Notice I am not writing equal to, I'm just writing that it sort of implies. that is 0 over 0, indeterminate. Okay, so we got indeterminate again, and once again, L'Hopital applies. L'Hopital applies. Get a little space there. So now I have to take that derivative again. So the limit as x approaches -1. Each time I take the limit, I have to write the limit as x approaches -1. It's a good idea to show that it's indeterminate each time and that you're using L'Hopital. So that's g prime, double prime of x over 6, taking the derivative of the denominator. This time it does not equal to 0 because the bottom is 6. And then the second derivative, which is what we found previously, evaluating that second derivative at -1, gives me -2. So you can leave your answer like this. If you want to be all fancy and do -1/3, you do not have to simplify, and I suggest that you don't simplify, because if you make a mistake, they're going to mark it wrong. So I would just leave my answer like this with no boxes around it. So this was worth 3 points. You got 1 point for the answer, and you got 2 points for applying L'Hopital. And when I say applying L'Hopital, I mean with all the correct notation, by saying that this was indeterminate, by using limit notation, and by showing that you had to use L'Hopital. So you had to show all 3 of these and, of course, get the right answer in order to get those 2 points. The last one, we had to use Euler's method. So we're going to start with x is equal to 0, y is equal to 2, and we're trying to get to 1 using 2 steps of equal size. So that means my delta x is 5, is 0.5. So we start off with the old y value times delta x multiplied by the derivative being evaluated at the old values. So we've already evaluated this at 0. So we're using 0.2 to evaluate that, and that gives us 0 minus 1/2 times 2. So that gives me, that's 0, so that's 1. It's -1. So 2 minus 1/2 is 3/2. So that's my new y. So then I do 3/2 plus 1/2. My old x is 1/2. My old y is 3/2. So that gives me 3/2 plus 1/4, I'm distributing, minus, this is 3/4, so that's minus 3/8. And this is a perfectly good answer. I would stop right here and say that's my answer. That's the approximation of when of y of 1, or h of 1, sorry. That's the approximation of h of 1. I would stop there. I would not try to simplify that. Okay? But if you did simplify it, I think the answer was 5/4. So this was worth 2 points. 1 for using Euler's method, and 1 for the answer, or for the approximation. That was worth 2 points. Okie dokie. Now we're going to do the next problem. This was also from, the average on this test was, on this question, was 4.68, so you can kind of score yourself and see how you did compared to national average. Also, there are a couple of things that they want you to know. These are important. These are some things that you need to make sure you know before you take the exam. You need to make sure you know the second derivative test. you need to be able to write things use mathematical expressions and notation. When evaluating a limit, use correct limit notation, meaning you should use, every time you take that limit, you should write the limit as. You should have to state that anytime you use a hypothesis, you have to state that the conditions are met to use that hypothesis. So before you could use L'Hopital rule, you had to state that it was indeterminate. Same thing for mean value theorem. Before you can use mean value theorem, you have to state that the function is continuous and differentiable. Here's something that's important. Your work should be organized and clear. A lot of times my students will come to me and they'll say, well, you made a mistake grading my paper, and that's fine, but just remember you won't be able to do that with the graders. So the more organized and the more neat your work is, the better it is for the graders, and everything should be labeled. If you can label it, take time to label it. It's not just enough to know how to do the problems, you need to be able to clearly communicate their solution process. So you need to be able to clearly communicate your solution process. Okay? All right, I'm running a little late, so I'm going to kind of rush through this one. This was also from 2016, and this was problem number 5, I think. I know that this problem was talked about on social media after the test. It is an A-B question, and although at first glance it may look difficult, it really was not that hard. So the first thing they ask you to do is to find the average value. Now, no offense, but if you can't find the average value at this point, you probably shouldn't be taking the exam. The average value is simply, well, if you can't find it, if you don't know it, you will now. The average value is simply 1 over b minus a times the integral from a to b of f of x. So that first question, all they were asking you to do was to find the average value of r. So that's 1 from 10 minus 0, the integral from 0 to 10 of 1 over 20, 3 plus h squared dh. So I'm hoping that everyone can do this. I'm just going to, so you got 1 point for this expression, for the integral. You got 1 point. So then this is 1 over 200, the integral from 0 to 10 of 3 plus h squared dh. I'm just cleaning that up a little bit. Taking the integral, I get 1 over 200, 3h plus 1/3 h cubed, evaluate it from 0 to 10. So this is 1 over 200, 30 plus 1,000 over 3 minus 0, and you do not have to simplify that. So you got 1 point for finding the antiderivative, and you got 1 point for the evaluation of it. So that's where your 3 points came from. Now, the B part was probably the most difficult part of that, but what you had to recall from when we do cross-sections, that volume is the integral of the area times the height. So it's the area times the height from A to B. So in this problem, the area of this is simply pi r squared. So my volume is going to be the integral from A to B, pi r squared times dh, because dh represents my height. My height is changing at every second. So this represents my height. So my formula becomes, I'm going to take out pi, and I'm integrating from 0 to 10, and r was given to us, so that's 1 over 20, 3 plus h squared, all of this squared, dh. So squaring this, I get 1 over 400, so I'm going to take that out. and I'm going to multiply this. So that gives me 9 plus 6h squared plus h to the 4th dh. So you got 1 point for this. I haven't taken the integral yet, so this is pi over 400, 9h plus 2h cubed plus h to the 5th over 5, evaluated from 0 to 10. So you got 1 point for this. Now you got 1 point for the evaluation. And once again, I think they were crazy to ask you to do this by hand, but nobody asked me. So this would be 90 plus 2,000 plus 10 to the 5th over 5. There is no way in Hades that I would have simplified this. I would have left this simply like this, and I would have gotten my 1 point, because you do not have to simplify that. Okay? You do not have to simplify, and if you simplify and get it wrong, it's wrong. So it's better. There's no incentive to go any further than that. So I would have left this like this and moved on with my life. Okay? If you are an overachiever and you want to simplify it, it's 2209. And I only know that because I'm looking at the rubric, 2209 pi over 40 inches cubed. They gave you units. Generally, when they give you units, you need to give them units back, although there were no points for the units on this. The last one, again, was not difficult if you just read the question. It's asking you at the instant when the height of the liquid is 3, the radius is decreasing at the rate of 1/5. At this instant, what is the rate of change of the height with respect to time? So what they want you to find is dh dt. So they give you dr dt. That's dr dt. So r is equal to 1 over 20, 3 plus h squared. So dr dt, because we're taking the derivative with respect to t, would be that 1 over 20 stays the same because it's a constant. The derivative of 3 is 0, so this would be 2h dh dt. And you have everything you need to know. dr dt is negative because it's decreasing. They gave you that h was 3, so this is 6 dh dt. So that gives me that negative 20 over 30 is equal to dh dt. So you got 2 points for writing that derivative, and you got 1 point for the answer. Okay? Here's some things that the graders want you to know. The average of this was 4.19. Now, questions A and question B both were very easy to do, so you should have, as a BC student, gotten at least 6 points on that. Okay? I love this statement by the graders, and your calculus teacher, we've been singing this song all year. It is disappointing when what appears as good conceptual understanding of calculus is diminished by poor algebra and arithmetic skills. In other words, you need to know your algebra and your arithmetic. So make sure that you know your algebra, and if you're not sure on your arithmetic, on adding fractions, don't try. Just leave it the way that it is. Don't try to simplify. You need to differentiate between average rate of change and average value. This volume correct question, know that it is cross sections are naturally presented as horizontal. And use appropriate derivative notation, okay? And remember, yes, use appropriate derivative notation, especially with chain rules. So you want to make sure when you take the derivative with respect to t that everything has to be taken with respect to t, okay? All righty. You are going to do so well on the AP exam. You are going to make a 5. Have an amazing day.